Okay, this is the synthesis of aspirin. The first step is to look up information in the Merck index. You will have to do that at another time. The next thing is to accurately weigh out an appropriate amount of salicylic acid, which is the starting material. And so here is the salicylic acid, so I have a jar of that. And I'm in the balance room to weigh this out. Okay, so you see the balance here. It's reading 0,011 negative. Okay, the comma is the decimal point. This is a balance from England, so they use a comma instead of a point. But we need to zero the balance. Okay, so now it reads 0, so I hit the 0 or tare button. Okay, on the balance pan there is a large weigh boat. That stays there because it protects the balance pan from chemical spills. We are going to put our small weigh boat on top of that. I'm going to put the cover back on to zero out the weight of the weigh boat. Okay, so now I'm going to weigh out the salicylic acid. Okay, you always weigh it with the air shield on. And so I have weighed out 2.011 grams. You always record all the decimal places that the balance gives you. Also note that the large weigh boat is not touching the air shield because that can give you an error. Okay, so I'm back over at the lab bench. I have my salicylic acid, so you can see that's a nice white solid. I have my test tube. I have to get all the salicylic acid into the test tube, and I've got a hot water bath heating up. So one of the ways to put this into the test tube is we use a plastic weigh boat, so we can bend this weigh boat and turn it into kind of a funnel. And then we can get the solid to, hopefully you can see that, to get down into the weigh boat here without spilling it. Okay, so now you may or may not be able to see, but there is still a little bit on the weigh boat that we can't get in there, okay, that won't get out of there. And there's a little bit up here at the top of the test tube that is not down where we're going to do the reaction, okay? But that's unavoidable in this case. Okay, so now I have to add the other reactants, which are acetic anhydride and acetic acid, but since those have a very strong odor, we have to go over the hood to do that. Okay, so we're over here by the hood. I have my acetic anhydride, okay, and I've already measured out 2 milliliters in this graduated cylinder, and I need to add that. And then I'll add 5 drops of acetic acid. And the glacial means it's concentrated in this case. And then I will stir it with this glass stir rod. Okay, so here comes the acetic anhydride. have to add the 5 drops of the acetic acid. So I've mixed it up, and now this will all dissolve as I heat it. So I have to go back over to my bath and we'll heat up this. Now it says to heat for 30 minutes. I'm not going to record all 30 minutes, but we'll show it at the end before we're done. So that way you'll get to make the observations. Okay, so the hot water bath is finally heated up. I'm going to stir this up a little bit. You can see I still have my the stuff is in the test tube. I'm going to lower it down into the hot water bath, and it has to stay there for 30 minutes. Okay. And we'll come back and check on it a couple of times. Okay, so it's been about 10 minutes, and you can see a good bit of the salicylic acid has dissolved. So if I stir it up here, still got a little bit that isn't dissolved. There's still some flecks in there, but most of it has dissolved here after 10 minutes. So we've got another 20 minutes to go in the hot water bath here. I'll zoom in so you can see that it's pretty much all dissolved at this point. Okay, so this is after a little more than 20 minutes. Okay, so not much change from the 10-minute. But I thought I'd show you what it looks like. Okay, and I still am mixing it every once in a while. Okay, it's been 30 minutes. I'm going to take the test tube, I'm going to lift it out of the hot water bath, and then I will dump it into this beaker that this Erlenmeyer flask that contains 30 mils of deionized water. Right, and to handle the test tube, since it's probably pretty hot, I'm going to use a test tube holder once I get it out of the clamp here to do that. And I'm sorry if I end up blocking the camera. Okay, so hopefully you're able to see that. Okay, so I'm trying to break up the globules. Of the acetic anhydride, and you should be able to see there's solid already forming. But what we're going to do is we're going to cap that, and I'm going to stick it into this ice water bath here. Get it good and cold. And then we'll filter the solid and isolate it. Okay, I've got to have it capped because I don't want it accidentally tipping over on us here. Okay, so while the aspirin is chilling in the ice ice water bath, I've put about 45 milliliters of water in a small Erlenmeyer and stuck that in the ice water bath as well, because it says that we're going to need to rinse our solid or wash our solid with ice cold water. Okay, but while that's chilling, I'm going to set up a vacuum filtration apparatus. What you'll need is you'll need a ring stand. You need your filter flask, which has the side arm here. You will need your Buchner funnel, right? That might be in 2 pieces. Okay. You'll need a rubber stopper that has a hole in it. Okay. You don't have this in your drawer. This we provide for you. You'll need your clamp and your thick-walled tubing. You'll also need a piece of filter paper, which again we will provide. Like so. Okay. Make sure I just get one. All right. So to set this up, right, we have our filter flask. What we need to do is we need to clamp the filter flask, because once we attach the rubber hose, it can tend to fly all over the place and it tends to break. So we're going to first we're going to clamp the flask to the ring stand. Okay. Now I'm going to lower it down so that the flask is setting flat, either against the lab bench or against the ring stand base. Okay, then I'm going to put the rubber stopper in there, and this goes through the rubber stopper, so, and we hook up the rubber tubing. Okay, so one end obviously goes on the flask. Where does the other end go? Well, obviously we don't hook it up here to the gas tap, okay, because that's for gas. We do not hook it to the bottom of the faucet, okay, because that's just going to let water in. What we want to do is we want to hook it to the side of an aspirator, okay. So let me zoom in on that so you can see the aspirator, hopefully. Okay, so you can see the aspirator here on the end. So I'm going to hook that onto there like so. Alright. And so now, when the water gets turned on, the water flowing down through the aspirator will pull gas molecules with it, which creates a vacuum in my filter flask. Alright, so I have my Buchner funnel up here. The last thing to do is put the piece of filter paper onto the Buchner funnel. Now, before I filter my aspirin, I have to wet the filter paper with a little bit of deionized water. Okay, I wet the filter paper, I turn on the water on the aspirator to create the vacuum that will suck the filter paper down onto the holes that are in the Buchner funnel and creates a good seal. Very soon after that is when I'm going to want to pour my aspirin mixture that I want to filter onto the filter paper before it dries out. Alright, and so then the liquid will go through here, the solid will stay up here, and we'll have separated our aspirin. So I'm going to let the aspirin chill a little bit longer, and then we'll go ahead and filter it. Okay, so the aspirin's been chilling for quite a while. You can see that there's a decent amount of solid in here. Okay, and I also have my water good and chilled for rinsing. So I'm about ready here to do the vacuum filtration. As I mentioned before, the first thing you do is you have to wet the filter paper a little bit, And then once I turn on the vacuum, turn on the aspirator, then I will dump our mixture onto the filter. Okay, so now I need to rinse this with water. I'm going to put the first bit of water into the flask and I'm going to rinse. Okay, I'm going to try to break up that solid as well. Okay, so I got a glass stir rod to break up the solid and get it off the bottom of the flask here and pour it onto my filter. Okay, try to get as much of the solid out as I can, but as you're going to note, right, there's no way I'm going to get it all out of there. Okay, but I'm trying to get as much of the solid out of there as I can. This is my aspirin here. Okay, I'm going to go ahead and rinse the second time. Again, I'm going to pour it into the flask here, swirl it around, try to get, like I say, try to get all the solid out of there if I can. All right. Okay, that's pretty good. That's about as much solid as I'm going to get out of that flask. All right, so I've got a little bit, about my third 15 ml portion. I'm just going to rinse the solid on the filter here. Okay. Okay, so this is to show you what it looks like on the filter there. Okay, so you can see that there's some crystalline bits and there's some stuff that's not as crystalline. And we're done filtering. There's no more liquid coming out of there. Okay, so what I'm doing now is just pulling some air through it with the vacuum here to try to dry it. But we're going to after this is done, we're going to stop the vacuum, and I'm going to put the solid and scrape it and put it onto this watch glass, and then I'm going to put it in the oven to dry, and we'll pick it back up after that, after I do that. So, to stop the vacuum, okay, you would think, okay, you just turn the water off. But if I turn the water off, there's still a vacuum in the flask here. And so some of the water would come back through the hose, perhaps, and into the flask. Now, in this case, we're not trying to keep the filtrate, so it wouldn't be the end of the world. But the better way to do this, in case sometimes you don't want the solid, you want the liquid, the best way to stop a vacuum filtration is to break the vacuum. And you can either break the vacuum here on the side of the filter flask, or you can break the vacuum by removing the hose off of there. And now I can turn the water off. Alright, so I've got my solid, and I'm going to then put it onto this watch glass. Alright, so I've got my little spatula here, porcelain spoon. I'm going to scrape all this solid out onto the watch glass. Okay. If you don't want to scrape too hard though, because you don't want to tear the filter paper. If the filter paper comes out of here, you can put that onto the watch glass as well. I mean, you can dry it and then scrape off the solid after it's dry. But this is, you know, it's not completely dry, but it's dry enough that it's coming off the filter paper pretty well here. Okay, so again, I'm trying to get all the solid because this is my yield here, apparently. Now, obviously, we're going to try to characterize it and purify it as well to make sure, because we have no idea for sure, we don't know for sure that this is aspirin or not. Okay, we're pretty sure it is. But the question is it pure aspirin or not? That's another question. Okay, so all right, so there's still some on the filter paper, but that's about as good as I can do. There's a little bit on the spatula, right? As we go along, every time you transfer, you tend to lose a little bit. All right, so that's our aspirin. Okay, so hopefully you can kind of see that. All right, I'm going to spread it out a little bit before it dries, so it dries a little better here. Okay. And then all we have to do is clean up. Okay, so I just pulled the aspirin out of the oven, and so it's dry, it's going to cool, and then I'm going to scrape it into a weigh boat and get a weight of our crude aspirin yield. Okay, so we're here in the balance room, and I'm going to put the weigh boat onto the balance and zero that out. Okay, and now I'm going to scrape the solid in there and we'll get a weight. So some of it's sticking on here pretty good. We got plenty, so be okay. Okay, so that's the weight of the crude aspirin, 1.899 grams.